Alright, so we're going to review for your chapter test. Keep in mind this is halfway through a unit. The unit is called Fields and Forces. So first we did electric. Okay, oops. We did our electric fields and forces. Okay. Electric fields and forces. Next we will be doing magnetic fields and forces and how they interact. So remember there's three methods of charging an object. And I'm not going to go through like super detail of everything because you need to look back in your notes and see that, but we'll just go over the main topics. So, charging by friction. This is where we start with two neutral objects like say a balloon and wool, and you rub them together. One object, the type of material, has the tendency to lose electrons, and another type of material has a tendency to gain electrons. So in the example of say the balloon and the wool has a tendency to lose electrons and it becomes positively charged, and the balloon has a tendency to gain electrons and becomes negatively charged. We could also charge by induction. There's no contact with that though. With these we just have a rearrangement of electrons. Okay. Charging by contact, this is where we have equal sharing of charges, and that's the conservation of charge, which is principle number 7. So if two charged objects touch, then they would transfer their charge of electrons so that they have balanced charges. That's principle number 7. We talked about the difference of electron movement in a conductor versus an insulator, so you'll want to review that. We talked about electroscopes and how they show us a really good example of what happens with induction and conduction. So you might want to review that. There will be definitely some questions on your chapter test that have electroscopes. Coulomb's law. It describes the relationship between the force created on the two charges depending on the distance, right? Distance is the key. The distance between the two charges, okay? So it shows us how strong that force is. Remember, we started this with taking a balloon that was charged and another balloon that was charged. We placed the one balloon down on the scale, and we brought the balloon closer and closer and closer, and what did we notice on the scale? There was a change in weight, okay? Because the weight is a force due to gravity, and we were actually creating more force on that balloon. So it showed us kind of what was happening with the force. Now this is our formula that's from Coulomb's law. So it's on your formula sheet, but you could only use this when it's like a source charge and another charge or point experiencing that field, okay? Not when you're doing parallel plates. Note, do not include the signs on the charges in the equation. You don't need them. You need to determine the direction yourself, okay, based on the electrostatic repulsion and attraction. So you have to go and look and see, okay, this charge and this charge, if they're positive and negative, they're going to be attracted. So there's a force going to be pulling the positive this way and a force pulling the negative this way. Okay, so you need to look and determine yourself which way the force is going. Don't get force confused with electrical field direction, okay? The electrical field can be one direction, but the force pushing or pulling the charge or the object could be in another direction, so be careful about that. When determining your net total force and direction on a charged object due to the presence of other charges, pretend the charge you are trying to find the net force on is mobile and all other charges are stationary. So it's, okay. So use trig and Pythagorean's theorem for 2D problems. So say if we have both our linear and our 2D problems. Okay, so say an example, this is just an example. Okay, So say we have charge here, oh, no red. I'll have, this is A, okay? Then I have, say, another charge here, this is C. And here's a charge B and it's negative. Okay. Say I'm trying to find the net force on C, okay? So how would I do that? Well, first you need to determine which direction each forces are coming from to label it either as negative or positive. So, say the force acting on C from B, okay? So think about it. C is going to be wanting to be pulled toward B, so the force from B on C is pulling it this way, okay? Now on A, however, it's both positive. So it's going to be pushing away, okay? So what we're going to do, since F of B is going to the left, I'm going to label that as a negative force, and F of A is going to the right, so I'm going to label that a positive force. That doesn't mean it came from the negative, well, it did, but I need to determine, okay, that is going to be negative just because it's going to the left, okay, just because it's going to the left. So this is negative F of B plus F of A, which is positive, okay? So it's like you add your forces together to find your F net, but you have to determine which forces are negative and which ones are positive. So just be careful and take your time with that, because it can be simple because you're like, oh, negative, positive, they're attracted to each other, okay? But just take your time to think about which direction specifically F net is going. Okay, so say we're doing 2D examples. So say we have, I'm going to go with the same color theme here. Here's A. And let's put B here in the middle. And C is over here. And it's going to also be positive. Okay? So it's positive. Alright, so what if the question asked me F net on B? Okay? So what's going on at B, at that spot? Well, from A, okay, so A is going to be forcing B up. So I'm going to draw an arrow up going F of A. Now B, or the charge on C, is going to be forcing B to go this way, okay? Because they're repelling each other, okay? So now what you need to do is you need to draw a new triangle that is tip to tail, okay? So your new triangle, you have F of A, and here's F of C. This overall, your hypotenuse will be your net, and here's your angle. Okay, your angle, you start at the tip or the tail of your hypotenuse for your net. Okay, so to find the magnitude of it would be the square root of F of A squared plus F of C squared. Okay, and you need to find your angle. We can find it using tan. So our inverse tan of A over C, okay? So make sure you're putting your directions like that too. All right, also you'll have free body diagrams like when you have your pith ball hanging down and you need to draw a free body diagram. So an example of that, say you have your pith ball, it's hanging from the ceiling, okay? So here's the ceiling. Say you're told this angle between the ceiling and the rope or whatever it's hanging from. So say here there's, I don't know, a rod that's charged negative, and I'll do blue for negative, and our ball is negative 2. So the force is acting on it. Well, it's going to have Fe pushing it that way. We have Ft and Fg. So in order to solve for any sides, depending kind of what you're given, if you're given the mass of the ball, you'll be able to figure out things too. So if we were to redraw this, we need to draw it tip to tail. So here we have our FG going down, our FE going across, so pencil that in, FE, and then we have our FT going sideways there, okay? Now, here's the kicker, is you have your angle between the ceiling and FT, so that's like this, right there, okay? Now, what you can do is, since this is a right angle, you can go 90 minus theta to get this, okay? 90 minus theta. So just be careful about reading which angle it gives you. If it gave you, like if it went down here and gave you this angle, then you could put that right into your triangle, but you just got to be careful there, okay? So you use trig and Pythag to solve for different sides. So you'll definitely have a free body diagram question of pith ball on your exam.